Good day. Today I'm going to show you how to prove the cosine rule. If you want to learn how to prove the sine rule and the error rule, the links to those videos are found at the end of this video. Let's begin. So we're going to prove the cosine rule by first using the acute angle triangle. Then we're going to deal with it in the obtuse angle triangle. You have to know both ways. So let's begin. Alright, let's call this triangle ABC. So what you'll do is that since angle A is facing this side, we will call it A. And since angle B is facing this side, you will call it B. And since angle C is facing this side, you will call it C. So what you're going to do next is that you're going to construct line AD. So we'll construct line AD. So we'll call this part D. And after constructing AD, you're going to say, let AD be H. So you're going to say, let AD be H. And the total length BC is still A. And since this construction that we drew separated these two, we're going to call this part X. And since this part is X, we have to find this part. And since this part is X, this part is going to be A minus X. The reason why it's going to be A minus X is because BD, which is this part, plus X is equals to A, which is the total length. So BD plus X is equals to A, which is the total length. And if we solve for BD, we're going to end up having BD is equals to A minus X, which is exactly what we got here. So because this part plus this part is equals to A, we had to solve it this way. And we'll end up getting this part as A minus X. So after this step, this becomes very easy to prove. All we have to do is to use Pythagoras theorem in this triangle. And we'll also use Pythagoras theorem in this triangle. So using Pythagoras theorem in triangle ABD, we'll end up having C squared is equals to this part which is H. So we're going to have H squared plus this part which is A minus X. So we're going to have A minus X, but we have to put it in brackets. We're going to have it squared. If we double the brackets and distribute, your answer will end up being C squared is equals to H squared. And then this part, when you double the brackets and distribute, your answer will end up being A squared minus 2AX plus X squared. There is a shortcut for this. So when you use the shortcut, it will just give you this answer straight. But you can also use the long cut. It will still give you the same answer. So from here, we've got our first equation. So we can call this our first equation. So we get the second equation by using this triangle, this time, triangle ADC. And we'll end up having B squared is equals to this side, which is X squared. So which is X squared, and this side, which is H squared. So we're going to have H squared. And we have to make H squared the subject of the formula because we want to get rid of it at the end. You'll see exactly what I mean. So we have to make it the subject. So if we make it the subject of the formula, we have to take this to the other side of the equation. So we can end up having B squared minus X squared. So this is what we have so far. So this is going to be our second equation. So what we did was just to use Pythagoras theorem in this triangle and to use Pythagoras theorem also in this triangle. And from here, we've got two equations. So we can substitute the second one into the first one. So we'll end up having, so when we substitute the second equation into the first one, it means wherever I see H squared, I have to replace it with this stuff in the first equation. So it means I'm going to write the first equation exactly the same, but wherever I see H squared, I'm going to replace it with this stuff. So we're going to end up having B squared minus X squared instead of writing H squared. And then this is going to be A squared minus 2AX plus X squared. So you would notice that these are like terms, so they just cancel. So when they cancel, we'll end up having C squared is equals to B squared plus A squared minus 2AX. We can even just rearrange it because we know the cosine rule is a squared plus b squared. So it's going to be a squared plus b squared. And we're going to have minus 2ax. So we just rearrange this stuff. So this looks like the cosine rule, because the cosine rule is c squared is equals to a squared plus b squared minus 2ab cos c. So that's the cosine rule. The only difference is here, instead of having b cos c, we've got x. So what do? We have to use trigonometry. So we know that we have to use c because the formula itself has got c. So let's proceed. So we have to use trigonometry. So if we say cos c, because the formula has got cos c, it's going to be adjacent over hypotenuse. So we know that cos is adjacent over hypotenuse. So our adjacent side is x and our hypotenuse is b. So what we have to do is to make x the subject of the formula. So we have to make x the subject of the formula. So then it's going to be b cos c, because we'll multiply both sides by b to get rid of b as the denominator. So we'll make x the subject of formula. So now we can substitute this into our equation. So let's call this equation 3 and let's call this equation 4. So we're going to tell them substitute. So we'll say substitute equation 4 into equation 3. So we'll substitute equation 4 into 3, meaning that in equation 3, wherever I see x, I have to replace it with this stuff, because x is equals to b cos c. So it just means I'll write equation 3 exactly the same, but instead of writing x, I will now replace it with b cos c. So since x is equals to b cos c, I have to replace it with b cos c. And notice, this is now the cosine rule. So now we've got the cosine rule. So we've proved it. There we have it. Now let's talk about proving it in the obtuse angle triangle. Just before I continue, if you want to be tutored, whether it is online or physically, whether it is the situation where you're struggling in maths or whether it is the situation where you're good in maths but want perfection, take a screenshot or save these details. Whether you're studying Cambridge, which is the UK curriculum, or whether you're studying NSC, which is the South African curriculum, or IEB, or native courses which start from N1 to N6, or any curriculum you're doing no matter which country you're at, we offer tutorials. We've got lessons and practice sessions 5 days a week. We also give you tests once a week so that we can check your improvements. Alright, here is an obtuse angle triangle. So what we're going to do is, since C corresponds to this side, we're going to call it C. And since B corresponds to this side, we're going to call it B. And since A corresponds to this side, we're going to call it A. And another thing that we're going to do is, whenever it comes to proving, we always need a perpendicular height. So we're going to construct a perpendicular height. So we'll call this point D, and we'll extend this line as well. The reason why we're extending it is because we're going to need to use the bigger triangle. So that is why we extend this part. And we're going to call this part X as before. So if this part is called X and this part is called A, it means the total of this part is just A plus X. So it means BD is equals to A plus X. So we found BD. And this time we're going to use Pythagoras for the bigger triangle and for the smaller triangle. So let's start with the bigger triangle. So we're allowed to use Pythagoras theorem because this is perpendicular. We constructed a perpendicular height, and let's call AD the perpendicular height. Let's call it H as usual. So using Pythagoras theorem for the bigger triangle, we'll end up having C squared is equals to H squared, which is the perpendicular height, which is this part, plus this part. So it's going to be plus, and this part, remember, it's the total, which is A plus X. So we're going to have A plus X, but we have to square it. So we have to put it in bracket. So this is what we're going to end up having. So we'll end up having c squared is equals to a squared. So since this is squared, you're going to double the brackets, and when you double the brackets and multiply, you'll end up having a squared plus 2ax plus x squared. So this is what you're going to have. So from here, we have created our first equation. So this is going to be our first equation. So now we're going to use Pythagoras theorem for the smaller triangle. So we're going to have the hypotenuse squared, which is b in this case. So we're going to have b squared is equals to, so this part is x. So we're going to have x squared, and this part we called it h. So we're going to have plus h squared. And we want to get rid of h because the formula for the cosine rule does not have h. The cosine rule is c squared is equals to a squared plus b squared minus 2ab cos c. So there is no h anywhere here. So since we want to get rid of it, we must make it the subject of the formula. So if we make it the subject of the formula, we end up having h squared is equals to b squared minus x squared, because we took this to the other side. So we're going to end up having, let's call this our equation 2. So this is going to be our equation 2. So when we substitute it into that equation, h is going to disappear. So now we're going to substitute. So we're going to say substitute equation 2 into equation 1. So I'm going to write this equation exactly the same. It's just that wherever I see h, instead of me writing h, I'll write this stuff. So it means that I'm going to have b squared minus x squared plus a squared plus 2ax plus x squared. So this is what we have so far. So let's group like terms. So we notice that this and this are like terms. So we're going to end up having c squared. So these two will just cancel out. So then we're going to end up having b squared plus a squared plus 2ax. And we can just rearrange them. So we know that c squared is equals to a squared plus b squared. So we're arranging them because we know that the constant rule is a squared plus b squared. So then we're going to have 2ax. So we just arrange this part. So this is what we have. So from here, it looks like the cosine rule, but the only problem we have is that instead of having AB cos C, we've got X. So what do we have to do? We have to use trigonometry as before. So let's use trigonometry. So we know that we have to use angle C because the formula is C. But the problem with it is that we can't use trigonometry here because this is not a right angle triangle. So what do we have to do? We have to use a right angle triangle. We have to use this triangle. So what we can do is that we can find this angle. So this particular angle is 180 minus C, because this plus this angle, which is C, it's up to 180. So if we use trigonometry, we know it's going to be cos because the formula is cos. So the formula for cosine rule is cos. So we're therefore going to say cos. So we know that cos is adjacent of a hypotenuse. So it's going to be cos 180 minus C, because this part is 180 minus C. So cos is equals to the adjacent side, which is x. So it's going to be equals to x over the hypotenuse. The hypotenuse side is b. So we're going to have x over b. And we also want to get rid of x because the formula does not have x. So because we have to get rid of it, we have to make it the subject of the formula. In order to make it the subject of formula, we have to multiply both sides by b. So we're going to end up having b cos 180 minus c. So b cos 180 minus c, and this part will be equals to x. So we've created our fourth equation. So our fourth equation was b cos 180 minus c is equals to x. So from here, we can just simply substitute. So this is going to be our fourth equation, and this that we created that almost looks like the cosine rule is going to be our third equation. So therefore, we're going to say substitute equation 4, rather not equation 3, substitute equation 4 into equation 3. So it means that in equation 3, wherever I see x, I have to replace it with this stuff because x is equals to this stuff. So it means I'm going to write my third equation exactly the same. So it's going to be c squared is equals to a squared plus b squared plus 2a. And instead of me writing x, I'm going to write what was x equals to, which was this stuff. So it's going to be b cos 180 minus c. So we're going to have cos 180 minus c. And then from here, I'm sure you notice that in the cosine rule, it's a minus, but here with a plus. So that part, we don't have to worry about it. What's going to happen here is that in trigonometry, when we've got 180 minus, we know it's in the second quadrant, and in the second quadrant, cos is negative. So it just means that it's going to be c squared is equals to a squared plus b squared. Now, because cos is negative, it means the negative will affect this sign. So this sign is just going to be negative. So we're going to end up having 2ab cos c. So we reduced it because if we have cos 180 minus x, for instance, we know that since it's negative in the second quadrant, it just becomes negative cos x. So we're just simplifying it using the same reduction rules. So there we have it. We've got the cosine rule. If you enjoyed this video, please like the video and subscribe to my channel. Any questions or any video you want me to make, please comment below. And if the contacts that I've provided in the advertisement are not working, please comment below.